for Learning Assessment 10.10, we want to determine I1, I2, V1, and V2 in the circuit shown below. We're going to use a problem-solving strategy entitled Circuits Containing Ideal Transformers. And if we look at the problem-solving strategy, we can look and see, for instance, that V1 is referenced positive at a dotted terminal. V2 is referenced positive in an undotted terminal. And according to our strategy then, we have V1 over N1 is equal to minus V2 over N2. And really, if we look, here's N1 and here's N2. So, looking at the turns ratio, we have V1 over 1 is minus V2 over 2. So V2 is going to be minus 2V1. Okay, we'll come back to that equation. Now, also note about the currents, that both currents are defined to be entering dots. So we have N1, I1 is equal to minus N2, I2. So we get I1 is equal to minus 2, I2. So there are our equations for our ideal transformer. Now if we look at our strategy, it says, step 4 says, if there are electrical connections between the two windings, use nodal analysis or mesh analysis to write equations for the circuit. And we have connections between the two windings, so we're going to need to use one of those analysis techniques. So here's our circuit, and let's use nodal analysis. I'm going to select this as a reference node, and really I'll have two unknown node voltages. I'll have one here that's V1, and I'll have another one here that's V2. And now what we're going to do is we're going to apply KCL to these to come up with nodal equations. So over here on the left, we'll have V1 minus 10 at an angle of 0 over 2. That's the current going that direction. We'll have V1 over 2. Then we'll have I1. And then we'll have V1 minus V2 over 2 equal to 0. So the I1 is here, and this is the current V1 minus V2. If we simplify that, we'll have 1.5 V1 minus 0.5 V2 plus I1 is equal to 5 at an angle of 0. So here's one of our equations. Now, let's go and apply KCL over at this node. We'll have V2 over J2. That's this current. We'll have I2 entering, so we've been summing currents leaving, so we have minus I2. Then we'll have V2 minus V1 over 2 equal to 0. That's a current going out that direction. So if we simplify this equation, we'll have minus 0.5 V1 plus 0.5 minus J 0.5 V2 minus I2 equal to 0. Okay. So here's a second equation. So now we've got two equations, but if you look, we've really got four unknowns. But if we look back to this previous page, we can see that we've really got two more equations here. Here's equations that relate V2 and V1 and I1 and I2. So we now have, with these two equations, we now have four equations with which to solve. So let's start solving. So let's take this equation and let's rearrange it. So we have I2 then is minus 0.5 V1 plus 0.5 minus J 0.5 V2. And now let's go in and substitute in V2 is minus 2V1 here. So making that substitution, and simplifying, we get I2 is minus 1.5 plus J1 times V1. And now if we remember that I1 is equal to the negative 2 I2, we get that I1 is 3 minus J2 times V1. Okay, so there's some simplification. Now let's go to this equation, and now let's go in and substitute for V2. Okay, so we have 1.5 V1 minus 0.5 V2 plus I1 equal 5 at an angle of 0. So we have 1.5 V1 minus 0.5. Now remember, V2 is minus 2 V1. And if we substitute in this expression, we'll have 3 minus J2 V1 equal 5 at an angle of 0. So we took this term and substituted in for I1. And when we do this, we'll get 5.5 minus J2 V1 equal 5 at an angle of 0. So now we can solve for V1 from that equation. Okay. So V1 is 5 at an angle of 0 divided by 5.5 minus J2. So it's 0.8544 at an angle of 20. V2 is minus 2V1, and that's 1.71 at an angle of minus 160. I1 is 3 minus J2 times V1, which is 3.08 at an angle of minus 13.71. And then I2 is minus 0.5 I1, and that's 1.54 at an angle of 166.3.